Okay, so on this question, the print is a little bit small there. It says, suppose that the speed at which cars go on the freeway is normally distributed. As soon as we see those words normally distributed, we know that means the bell curve, right? The bell with mean 68 miles per hour, that's the average, standard deviation 5. Let X be the speed, blah, blah, blah. First thing they want us to do is they have this in here, and that stands for normally distributed. And all they want you to do is they want you to put the mean in the first blank and the standard deviation in the second. So the mean is 68 for mine and the standard deviation is 5. So that all we're doing there is just making sure we understand that we're dealing with a bell curve, a normal curve. That's what the in stands for, with middle, mean 68, and standard deviation, that's how wide the spread is, 5. That's all that is. That's a no-brainer. Just put in, it's going to be every one of these problems is going to start with that. Every one of the problems here on quiz 6 is going to start where you put in the mean and you put in the standard deviation. Remember, with quizzes, it's not going to tell you right or wrong until you submit the whole quiz at the end, which is a bit of a bummer, but it does help us be more careful. So mean, standard deviation, here we go on part B. If one car is randomly chosen, find the probability that it is traveling more than 70 miles per hour. More than 70. Okay, how do I do that? Well, let me go to the notes with you real quick. They'll help us. The exam 2 notes. And it's just right there. Yeah, there it is. Okay. So this is the exam 2 notes. Okay, and it tells us, in fact, we can pretty much ignore these two for now. So we're just going to use this one and this one for now. So chapter 7, we'll use these other two. Anyway, that's not today. Chapter 6 is today. So first up, they're either asking for a percentage or giving you a percentage. That's the key that helps you know whether you're going to do normal CDF on the calculator or inverse norm on the calculator. Are they asking you for a percentage or giving you a percentage? Let's go see. On question B, one car is randomly chosen. Find the probability. That's a percentage, right? Probability is percentage. When they say find the probability, if I said, what's the probability of rain today? You might say 5%. So that's a percentage, right? So they're saying find the probability. They're asking for a percentage, aren't they? They're asking for it. They're asking for a percentage, right? They're asking for a percentage. So we're going to use normal CDF. All right, so that's what the notes tell us. So for part B, I'll bring it down here. For part B, I'm going to do normal. Oh, so, and to get there, remember on the calculator, you have to hit second and then vars, the vars button, second vars, and then choose normal CDF. I think that's number 2. Choose normal CDF. And then when you do, it'll ask you lower, upper, mu, and sigma. Now the mu and the sigma, that's the mean and the standard deviation. So those are easy. The mean is 68. That'll just be 68. Standard deviation is 5. Those are the easy parts. But what do we do for lower and upper? Well, it's helpful to draw a little normal curve. So I'm going to draw a little normal curve here. It's always good to draw that on all these problems. And then to put in the very center the mean is 68. Okay. And then put on the question, what they're asking. What are they asking? More than 70. Well, 70 is to the right of 68. Right? It's bigger. And more is this way, isn't it? Are you with me? Why I'm saying that? Remember this line down here, this bottom of the bell curve, it's like a number line. You know what I mean? There's 68, 70, and way over on the right is plus 5 9s because that's infinity, and way over on the left is minus 5 9s because that's like negative infinity. Way over there, right? Remember how that works? Is negative infinity. And this is positive infinity, right forever. So the way we do infinity on the calculator is we do 5 9s positive, or for negative infinity, 5 9s negative. So remember, it's a number line. 68 is in the middle. It's a number line with 68 in the middle. Bigger numbers are to the right, all the way up to positive infinity. And smaller numbers are on the left, all the way down to negative 5 nines, negative infinity. Okay, so when they say more than 70, I'm going to put a line at 70 and I'm going to shade to the right. It's very important that you shade on your bell curve. The shading tells us what we're looking for. How did I know to shade to the right? Well, because they said more. If they had said less, if they said less than 70, then I would have shaded everything to the left of 70. Is that making sense? If they say more, shade to the right. If they say less, shade to the left. Because bigger numbers are right and smaller numbers are left. Okay, so now when we come to this lower upper, what does lower upper mean? Well, lower and upper mean really the left edge of the shading and the right edge of the shading. That's what they mean by lower and upper, is left edge, right edge of the shading. So what is the left edge and what is the right edge? Well, here's the left and here's the right of the shading. Do you see what I mean? So this is the piece of shading right here, and his left edge is 70 and his right edge is right forever, which is positive infinity, and we just do positive 5 nines. So I'm going to go left edge 70, right edge positive 5 nines. So put that into your calculator, hit the buttons, and they want all answers. It says up here, round all answers to 2 decimal places. So again, I want to emphasize one more time that you have to do the shading on the bell curve. And once you've got the shading, that tells you the lower and upper. Why? Because the lower is the left edge of the piece of shading, and the upper is the right edge. This is the lower, this is the upper. It's the left edge and right edge of the piece of shading. Since my shading went right forever, my right edge is positive infinity or positive 5 nines. If you have shading that goes left forever, then your left edge will be negative infinity or negative 5 nines. Does that make sense? It's the lower and the upper are the left edge and the right edge of the piece of shading. And so if that goes right forever or left forever, you're going to have the 5 nines, positive or negative. Okay, now I'm going to go to the calculator and I'm going to show how to do this on the calculator. So I'm going to put in, let me get the calculator open here. There it is. Okay, clear that. All right, so we hit second vars and go down to normal CDF, hit enter. And there it is, lower, upper, mu, and sigma. So the lower is 70, enter, hit enter. And the upper is the 5 nines, 1, 2, 3, 4, 5. You can do 6 or 7 nines, whatever, it just means infinity to the calculator. The mu, that's a Greek M for the mean, 68. And the little circle thing, which is a sigma, the Greek S, stands for standard deviation, which in our case is 5. And then hit enter a couple times, and there's my answer. 0.34457. So I'm supposed to round to 2. What did it say? Round all answers to 2. So that'd be 0.34. So 0.34 on that one. All right. I'll go back. Sharing my iPad screen. All right, yes, so that one is, so the answer to part B here, this comes out to be 0.34. All right, now for part C. Coming on down for part C. What's part C says? So down, says one of the cars rounds to find the probability of travel between 65 and 75. Okay, so gonna draw ourselves a little bell curve. Okay, and we always put the center, which is 68. That's the mean, right? And they said between what? Well, 65 and 75. Okay, so where's that? Well, 65 is about right here, just a little left of 68, and 75 is a little further to the right. And they said between, so that would be shading in between, huh? Again, this is going to be second VARS normal CDF, because why? Because they're asking for a percentage. They're asking for it again, as the old saying goes, right? It says find the probability. That's asking for a percentage. Probability is a percent, isn't it? They're saying find the percent, find the probability. So that's second VARS normal CDF again, and it's going to be the whole lower, upper, mu and sigma. Mu is the mean, sigma is the standard deviation. Again, that's 68 and 5. Those don't change. But what's the lower and the upper now? It's just the 65 and the 75. This is actually easier. We don't have any 5 9s on this one. Why? Because the left edge and the right edge of the piece of shading are just obviously 65 and 75, aren't they? You see that? This is the left edge, and this is the right edge of the shading, of the piece of shading. Right? Left edge, right edge. So that's easier. So notice the shading on part C does not go right forever nor left forever. Whereas back up on part B, it did. Why did it go right forever? Because they just said more than 70. You know, more than 70, that could be 10 million, right? That's more than 70. So more than 70 goes right forever. That's why I use the positive infinity, the positive 5 9s. For my right edge, my upper is actually infinity. Whereas on this one, they said between 65 and 75. So that's the lower and the upper. So put that into the calculator, get an answer. Now, the part I really wanted to show you is D. Let's come on down and do the big dog here, which is D. So grabbing on to D, coming on down. What does it say? It says 90% of all cars travel at least how fast on the freeway? Okay, let's draw a bell curve and try to get a good feel for that. So I'm going to draw a bell curve down here, and put a bell curve like that, and put the middle on there. You know, that's what we always do. So 68 like that, right? Okay, now this is the part that I know confuses a lot of people, and it's not easy. It is tricky. I want to help with this. So what does it mean when it says 90% travel at least how fast? It means there's some low speed and 90%, put it in here, are to the right. 0.90. That's what it means. It means find this spot, this low speed, right? They're saying, let's go back here. The average speed on the freeway is 68 miles an hour, right? And then they're saying 90% of all cars travel at least how fast? So we want to find some low speed, right? And maybe, I don't know what it is. I mean, let me just guess to make, let's say 55. So maybe 90.90 or 90% of all cars travel at least. Remember, at least means at lowest 55 miles an hour. I don't know, I'm just guessing, right? Maybe that's, I'm just going to do, I'll find the answer in a minute, but let's just pretend it's 55 to help you think about what it's really saying. You know, if it's 55, then we'd say at least 90% of all the cars travel at least 55, right? That's like the minimum, right? Even though technically it's the maximum in some places. We know how traffic goes, and so that might be the case, right? So it might be the case that 90% of all the drivers on the freeway travel at least 55. You see, the fact that they said at least, at lowest 55, means that or more, doesn't it? It's 55 or more. That's what at lowest or at least 55 means. At the lowest 55, maybe more, 55 or more. That's what it means, huh? So we want to, now I don't know it's really 55. I'll change this now to question mark and question mark. and question mark. That's what I'm trying to find. What speed? Is it 52, 53? What speed? You know, what speed or more is what 90% of the drivers do? That's what they're asking. They're saying 90% of all the drivers travel at least how fast? At least how fast? Okay, so well, how am I going to do that? Well, let's go back to the notes. So remember right here to the notes, the exam 2 notes. So are they asking us for a percentage or giving us a percentage? They're giving us a percentage, right? They're right here. It says 90% right in the problem. They're giving us a percentage, aren't they? So that's this right here. They're giving us a percentage, inverse norm on the calculator. Okay, right? So let's fill in the details here. So they're giving us a percentage. So I'm going to go second vars. And I'm going to go to inverse norm, which is like the third option. Inverse norm, right? Okay, and then what are you going to do on that? Well, it has 3 options. It has area, and then, you know, mu and sigma, those are the same. Mean, standard deviation, no big deal, right? And that's the same as it always was. I mean, you know, it's the middle still 68, standard deviation was at 5? Yeah, 5, right? You know, what cars differ from the average by about 5 miles an hour, right? The average car goes 68 in the freeway, but they don't all go average. The standard deviation, you know, typical distance from the middle is about 5. People go above it or below it by 5. Anyway, what's the area? What do we put in there for area? Do we put, so here's the tricky part. Do we put 90%? No, that's the mistake most people make. Why? This means area to the left of the spot you want to find. Area to the left of the spot you want to find. What's that? That's here. This is area left, right? I'm trying hard to find this spot right here, this question mark spot, this low speed that 90% of the people do higher than, right? To find that, I got to have the area to the left. Well, what's the area to the left? If this is 90% of the candy bar, I always use candy bar. What is the percentage here?
10.
I couldn't quite hear, but I'm assuming you said 10%.
10.
Right, exactly, 10%, huh? Does that make sense? So what I put in for area there is point, you got to put the decimal, 0.10. There it is. And then hit the buttons on your calculator. Does that make sense? Whenever you use inverse, so you got to remember, whenever you use inverse norm, when they give you a percentage, you've got to put area to the left. There's a real temptation. Oh, it's 90%, put it into 90. No, that's the area to the right. Now, they could have programmed it that way. They just didn't. The people that programmed, and that's how technology works in the real world. Programmers program things a certain way, and we have to know as a user how it's programmed and therefore how we use it. So it has to be area to the left. That's how they programmed it. So if it's 90% to the right, then it's 10% to the left. And I put that in the notes for you. I put it right here, area to the left. So you'll know to help you. So area to the left, so that's 10% is to the left. Type that in, you'll get your answer. Now, let me mention, there's another one just like this that mentions the Piggy Award. There's another problem, and it talks about the Piggy Award, and it says it's the top 1%, the real pigs that pig out and eat the top 1% of the food. And okay, think about what that would be. Well, if it's top 1%, then that'd be up here, right? 0.01, top 1%. So when you're going to do inverse norm on that one also inverse norm, and you're going to do area, mu, sigma, it's all the same. This, but what would your area be in this case?
0.99.
Exactly. You guys are getting it. It would be all of this would be 0.99 because again, it's got to be area to the left, doesn't it? So if you're talking about the top 1% of eaters, then that's 99% is the area to the left. So watch out for that. Whenever you do an inverse norm,
How is that question structured exactly?
I don't remember the rest of it. The rest of it is, stuff like this. But the final and hardest part, they say, you want to find like how much people eat right here that eat in the top 1%.
I have
And
a question that says the fastest 2% of laps are under. So I'm assuming that that question is structured the same.
No, that one's
No?
tricky. Good question. And yeah, let me mention that one. I'm glad you brought that one up. That's super tricky too. Let me put a bell curve. Okay. Yeah, let's talk about that one. Fastest 2%. Now, your bell curve, what do you have in the middle there?
My mean is 129.71.
129.7?
71.
71. Okay. And what are the units on that? Isn't that like minutes or something?
Seconds.
What is it?
Seconds.
Oh, seconds. Okay. Yeah, seconds. And what is that? This is for the motorcycle racer, right?
Yes.
Yeah. So think about it for a second with me. This is a motorcycle racer. And these are times, right? 129 seconds. That's how long it takes her to do whatever it is, 3 or 4, 2.5 laps, I think, or whatever, right? So her fastest trips are going to actually be where? Down here, right? Lower times, right?
Okay,
Because if
that makes sense. I was just thrown off because it said fastest. So fastest I would have thought was going to be on the other side, but then
I know.
So then I was confused.
Yeah, and I wrote fattest. I don't think that's helpful. Yeah, it's fastest. Yeah, I know. That's a good question on that one. Everybody see that? So if you're doing the motorcycle race one, yeah, fastest means
So then
lower
for this one, I'll
times.
do the normal CDF with the lower being the -999 and the upper being the 0.02.
So for the motorcycle one, you'll do inverse norm, and the area to the left, that is just straight out the 0.02. Because for this spot right here, the area to the left is 0.02 in the mu and the sigma. So they are giving you the area to the left. You just put it in directly 0.02. But for this one up here with the Piggy Award, they're telling you top 1%. So area to the left is 99%. For this one up here, where I'm putting in the car travels on the freeway, they want the top 90%. So the area to the left is 0.10. That making sense? So that's how we do those.